Now, we're now going to try to add vectors. The first method we're going to learn is how to add vectors graphically. In this method, you're going to need pen, paper, and a ruler. The first method under graphical method is the parallelogram method. From the term itself, we have to create a parallelogram. To do this, we have to literally copy the two vectors that we're trying to add. So, just a disclaimer, since tinatansya ko lang yung pinaka-arrows ko dito, I'll not be making perfect lines, but the principle should be there. So, please remember that first, you have to literally copy the length of the vector you want to copy. For example, if B has a length of 3 centimeters, if you try to copy B and put it here, it should also be 3 centimeters. Next is the direction. Now, the direction would be reflected as the angle. So, if letter B, for example, is, we have here, let's say, 30 degrees, based on the negative y, and if we try to put it here, and then copy letter B with the same 3 centimeter, again, tinatansya ko lang po, we should also follow its degree, which is 30 degrees here. And this will now be your vector B copy. And same goes for vector A. For example, vector A, with the base of the positive x is, let's say, 40 degrees, and it has a length of 2 centimeters. If we try to copy that, we can put here another copy, and this should be 40 degrees still, using the positive x as the base, and this should also be 2 centimeter in length. Now, to find the resultant vector of A plus B, we just have to connect the origin and the endpoint whereas those copied vectors meet. So this will now be this part, and then up to this part. So this up to this one. So I'm going to draw that. So this will now be your resultant vector. Now what will now be the magnitude? Since this is graphical method, you have to measure it using your ruler. So since I am doing it electronically, I'm just going to assume that this is about 7 to 8 centimeter, let's say 7 centimeter. So for just for example, so that will now be 7 centimeter. That is now your resultant for this example. Let's try it again. First, we have to copy again this vector D and put it on the tip of the other vector, which is the vector C. We have to copy its length and copy its direction. So assuming, since this is, I'm just going to try to measure my screen. In my screen, that is about 6.5, for example. So letter D is 6.5 centimeter. And letter C is about 6 centimeter. And the angle for that letter D, let's say, basing on the negative y-axis, let's say 20 degrees. This one is about, let's say, 1 degree. Kasi it's not directed on the positive x. Meron siyang konting angat. Okay. First, I'm going to literally copy vector D and put it on the tip. Put the tail of letter D on the tip of letter C. In a while. Then, siguro mga dito siya hanggang dito. Say. Yan. Example, that is now your vector, a copy of your vector D. As you can see, it's not perfect, but you get the idea. You have to literally copy it using your ruler. Medyo mahirap lang when it's on screen. So this is now the copy of vector D. It should have the same size, which is 6.5 meter, and the same angle, which is 20 degrees, using the negative y as your base. Then you now have to copy letter C. Put the tail of letter C on the tip of letter D. I'm just going to tatansyahin ko lang po kung saan po siya. Here, up to maybe here. Okay, so this is now your vector C. This is the arrowhead for vector C. Again, same size, which is 6 centimeter dapat, and using the positive x-axis, which is 1 degree. How we can now find the resultant vector? We are going from the origin of those two vectors that we have added up to the end, whereas those two met. So I'm going to draw that from here, and then dito, here to here. Okay, so that is now your resultant vector. Again, if you try to search the magnitude of that resultant vector, you should literally measure it. So in my case, that would be about 10 centimeter using my screen. So that will now be 10 centimeter. So that's how you add vectors graphically using the parallelogram method. Adding vectors graphically using the parallelogram method has its limitation. For one, we can only add 2 vectors. To solve this, this is where the tip-to-tail method comes in. In adding vectors graphically using the tip-to-tail method, we have to literally move a vector of our choice. For example, if we have chosen vector A as the vector na i-move natin, this one will now change its position from this part up to this part. Now, why is it called the tip-to-tail method? Because the tip of the origin vector, meaning the vector that we did not move, would connect to the tail of the vector that we have moved. In this example, I have chosen vector A as the vector to be moved to the other side. Still following the 2 rules, which is 1, do not change the length because the length signifies the magnitude, and do not change the direction since the direction signifies the angle. So what I'm going to do now is to analyze vector A. First, I'm going to plot here an imaginary Cartesian plane. This is the positive x. And for example, this has an angle of 20 degrees and has a magnitude or a length of about 3 centimeters. That should also be the case when I try to move vector A. So if, for example, I try to move vector A here, I should still have it on a 20-degree angle with a length of still 3 centimeter. Okay? So this will now be erased since I have moved it. Unlike the parallelogram method where you have copied it, on adding vectors using the tip-to-tail, you are going to copy it. In writing the resultant, same as the parallelogram method, we have to start with the origin. The origin would now be the vector that we did not move. And kung saan siya nag-start, that will now be the origin of those 2 vectors that we are trying to add. So meaning, if this is now the origin, now I'm just going to plot kung saan yung mga ito. Okay, for example, this is the part, moves. So tansyahin ko na lang. As you can see here, I started at the origin of B kasi nga siya yung hindi ko minove, and I'll end it on the tip of A. So this vector now is my resultant vector using the tip-to-tail method. The magnitude of this one would depend kung what is its physical length. For example, that is about, let's say, 12 centimeter. So that is now the magnitude of this vector if we try to add it using the tip-to-tail method. A while ago, we have stated that One limitation of adding vectors graphically using the parallelogram method is that we cannot add 2 or more vectors. And we have also said that that problem can be answered using the tip-to-tail method. So let's try. For example, we have here your vector A, vector B, and then vector C. We're going to try to add them using the tip-to-tail method. Again, you have to put the tail on the tip of the vector of your origin vector. For example, I'm going to start first by moving vector A. I'm choosing vector B as my origin vector. So I'm going to move A. I'm going to put the tail of vector A on the tip of vector B, still following the 2 principle of length and direction. So first, again, you analyze what's the length. For example, this is 30 degree. This is, for example, about 3 centimeter. Again, follow the length and the direction. So, tansyahan, I'm going to put here a guide. And for example, this is now your moved vector A that would have an angle of 30 degrees and a length of 3 centimeter. 3 centimeter. Now, I have now moved A, so it shouldn't exist here. Na-move ko na siya dito. Now, if we try to move vector C, still same process. For example, this is still our guide. And then I'm going to put my reference angle here. Let's say this is about 35 degrees. And then the length of C is 2.8 centimeter. Okay? I'm now going to move vector C towards this, since this is now our endpoint and not the B. So, tansyahan. For example, this is now our vector C with a length of 2.8 centimeter and an angle of 35 degrees on x-axis as is reference. In writing the resultant, we are still going to follow the same rule. The starting point would be the origin of the base vector, which is B. So from there, you're going to draw up to the end point. The end point now would now be the tip of vector C. So just sketch that out. So from there to there. So this now, kung gaano man yan kahaba, will now be the resultant of vector A, B, and C. For example, that is about 12 centimeter. Nari lang. So that is now your magnitude for R. Please remember that no matter what you move, for example, you choose C as your base angle, you will still have the same result. So let's try. For example, C is your base. So this is your vector C. Then I put A before B. So I'm going to draw here vector A. And then redraw vector B. This one. And then if I try to draw the resultant vector, I'm going to start with the origin, which will now be the base of letter C, up to the end point of B. As you can see here, we still have the same arrow there. Katulad neto. Okay? Try naman natin na A yung base. So this is vector A. Then, we now try to put vector B. So ito yung vector B. Then add vector C. As you can see here, from the origin of our base vector up to the end of vector C, we are still going to have the same result. We're now done on adding vectors graphically. We're now going to move on how to add vectors analytically. When we say analytically, this can be also stated as adding vectors numerically, because we're going to use now mathematical processes as our mean. We're going to analyze the logic or the concept of adding vectors numerically. Since it's numerically and adding vectors, the mathematical process would also always be addition. Now, if we try to add vectors with the same direction, going to the right, we're just going to put here 5 plus 2. We're now going to have 7 newtons directed on the x-axis. However, what if the other vector is actually going on the opposite direction? So this is going to the right and the other one is going to the left. Our mathematical process will now be 5 plus minus 2 that will now be equal to 3 Newton, still on the x-axis. Okay, for our first example, we're going to try to find the resultant vector of vector A and then vector B. Vector A has a magnitude of 6 Newton and vector B has a magnitude of 4 newtons. So let's have some sort of example here. For example, we have here a box, a heavy box, being pulled by a crane towards this direction, that would be vector A, with a force of 6 Newton. And we also have here, it's also being tied by a rope that is directed on this direction with an angle of 30 degrees and being pulled with a force of 4 Newton. Now, what will now be the resultant vector of this situation? First, I suggest you actually take a look at the vectors separately. On our previous topic, I have asked you to find out the component of a vector. We are still going to follow it here. As an organizational process or step, I suggest you create a table of vector forces, enumerating the forces on the x-axis and then the forces on the y-axis. So, the vector forces that we are adding is vector A and vector B, and we are going to add this to produce the resultant vector. Now, we can go about in plugging in the vector forces of A, since if we're going to observe vector A, it's already on the x-axis and it's not directed at an angle, meaning it will have a 0 value Newton on its y, and whatever the magnitude is of vector A, all of that will be directed on the x-axis. That will now be 6n. We now have our concern for vector B. So for vector B, we have to first find its resultant vector, which will be the x and the y, before we can add them together. Now, to do that, we have to separately analyze vector B. So I'm going to draw here vector B. This is now a representation of vector B with a magnitude of 4 newtons and at an angle of 30 degrees. Now, again, just like what we have taught a while ago, vector B is already a resultant vector, meaning it has its component. So that will be component Bx, which means the force on the x-axis of letter B, and component By. Following the principle that we can actually move vector as long as we don't change its length and direction, I'm going to now move vector By in this area. So this is now my vector By. Okay? Analyzing if it's opposite or adjacent on this angle, Bx will now be the adjacent, meaning I should use the Ka on SOHCAHTOA formula, and this By will now be the opposite, and so I'm going to use So on SOHCAHTOA. So if you cannot recall how did we do that, please go back to the previous slides. So finding By, this will now be B, since B is the hypotenuse, and this is SOH, that will now be sine theta. Plugging in the values, that would be 4 sine 30 degrees. Then, going to put here on my calculator, 4 sine, that is now 2 newtons. For x, going to put here B, CAH, or Ka, that will be cosine theta is equal to 4 cosine 30 degrees. Computing that, that is 4 cosine 30. That will now become 3.46 Newton. So those are now your x and y value. Plugging it here, 3.46 Newton and 2 newtons. So these are now your value. since they are now on the same dimension, you can now add them because this 6 and 3.46 are all on the x dimension and 0 and 2 are all on the y dimension. Adding that, we're going to have 9.46 Newton and, of course, 2 newtons. However, this process is not yet done. We have to now write its direction. We have now plugged in the value of 2 Newton, which is this one, and 3.46 Newton on this value. However, do not forget to write its direction. For example, 3.46 Newton is a positive 3.46 since if we're going to observe Bx, it's actually directed to the right. So, we can write it as this way, while 2 Newton is directed upward, which means it's also positive. However, please remember, for example, that we have here a value of, if we have an illustration rather, which is directed downward, this 2 Newton will now become 2 Newton. So that will be 0 plus negative 2. So this will now be negative 2 newtons. For example, again, 3.46 is not directed to the right, rather it's directed to the left. So that will now be negative 3.46 newtons. So that will be 6 Newton plus the negative 3.46, which will have a value of 2.54. So you're going to have a different result. Okay? So on this juncture, we now have to find the value of R using our previous values. So our value of Rx is 9.46 Newton and our value of Ry is 2 newtons. Let's write it down. So R is actually Rx plus Ry, which means resultant, which is a value of 9.46 Newton plus 2 Newton. Again, we cannot add these two since they are now on different dimension, unlike the previous setup. So what we're going to do now is use the Pythagorean theorem. So it will be R is equal to the square root of 9.46 squared plus 2 newtons squared. So let's square first 9.46. 9.46 squared. So we're going to have 89.49 plus 4. Plugging that on the calculator, we're going to have 89.49 plus 4. The answer here would be 9.67 Newton. So the value of our resultant is 9.67 Newton. Now, what if we want to draw that? What if we want to illustrate that vector? So first, we can also use this value. Patansyahin lang natin. So this is a positive 9.46. So that will be directed toward the right. Katulad nito. As our Rx, 9.46. And we also have 2 Newton upward. So mga ganito. So Ry is equal to 2 Newton. Using the tip-to-tail method, from the origin up to the end, we can just draw it here. That is now your R. We can also search the angle using the OA, but we're going to skip that for now since we are just trying to find the resultant. So meaning the value of this force is actually 9.67 Newton. That is now your resultant vector. Okay, for example number 2, as you can see here, we have a different scenario. Both of them are now at an angle. Same strategy, please create your table first so you can be organized in finding your answers. So we have C and D, that would be 2 vector plus the resultant vector. And then of course we have the X and Y dimension. So going to write here X, then Y. We have vector C, we have here vector D, and we are trying to search for the resultant vector. Okay, so let's try to analyze first. We're going to start analyzing first vector D. So to do that, I'm going to separately discuss vector D. So this is my vector D. I'm going to just transfer that image here. Vector D has a magnitude of 3 newtons and it's an angle of 30 degrees. Again, I'm going to illustrate its resultant vector. This will now be dx, dx, and I have here dy. I'm trying to search the following values here. Again, we can move vectors as long as we don't change the length and direction. So I'm going to move this dy in this part. That is now my dy. Then I'll analyze if it's the opposite or adjacent. So dy, as you can see here, is the opposite of 30 degrees. So that will be so katawa. So my value here would be d. So that will now be sine theta. Meanwhile, dx is adjacent. So that's ka or cosine theta. So that will now be d cosine theta. So these are now my formula in finding the x and y components. So let's try. Let's start first with dx is equal to d. That is a value of 3 cosine 30 degrees. The answer there would be 2.60. So 2.60 newtons. That's the value of dx. Meanwhile, dy, that would also be 3, but it will now be sine 30 degrees. Solving that, that will be 1.5 Newton. This time, before we actually put it here, what we're going to do is to analyze already its direction. So dx, if we're going to look at its illustration here, it's actually pointing to the right. Meaning, this answer here should be enough, and we can put it directly here as 2.60 newtons. For dy, we also have that same value, same sign, since it's also directed upward. So we can write here 1.5 newtons. Okay, so that will now be the value of our dy, of our d and its component. Analyzing vector c, as you can see here, it's quite tricky since nasa 20 degrees siya. Okay, we can do that. However, we have to follow the same base here. So we can create an angle here just by adding this 2. So same x-axis here. So this will now be 50 degrees. C is equal to 5 Newton. This is now Cx. And again, you'll have Cy. Moving this vector here, Cy. Analyzing through SOHCAHTOA, this is now the opposite. And this is now your adjacent. Okay, going directly to our formula, dx will now be adjacent, so ka. That will be d cosine 50 degrees. And dy will now be d so or sine theta sine 50 degrees. So let's try to compute that. So d has a value of 5. So 5 cosine 50. So that's 3.21. So we'll have here 3.21 Newton. Then still 5 sine 50. Sorry, sine 50. That's 3.83. 3.83 newtons. Now plugging this value on our table, Cx will now be, so this should be C, should be C. So Cx will now be 3.21 Newton. And then Cy will now be 3.83 Newton. Okay, still they are both positive. As you can see here, short version is that C is on quadrant 2, whereas the value should be of the x and y will be positive, positive. Adding those, we have 3.21 plus 2.60. We'll have 5.81 and 3.85 plus 1.5. That is 5.35. Okay, these are now our value of our Rx and Ry. Writing it down in component form, we have Rx plus Ry, plus Ry. That will now become 5.81 plus 5.35 square root of the squared, since we want to find the value of R, square root of 5.81 squared plus 5.35 squared. The answer there would be, this is 33.75 plus 5.35 squared, that is 28.62. 28.62. Now, the value for that would be 7.898. So that will be 7.90 newtons. So that will now be the resultant value of your R. So R is equal to 7.90 newtons. So this is now your answer for the resultant vector of this illustration. Now, ano ngayon yung magiging itsura niyan? Again, please go back here. That would be 5.81, about 6 for example. Tansyahin lang natin. This is now your Rx. And 5.35, about the same size. So this will be our Ry, meaning this is now your resultant vector with a magnitude of 7.90 newtons. So for example number 3, we're going to try to solve this problem. An unknown particle is moving 5 meters per second to the east, and then 8 meters per second southwest. We want to calculate the resultant velocity of the particle. So it's better again to first illustrate that. It's moving 5 meters per second to the east. So this particle is moving 5 meters per second to the east. So that's a velocity of 5 meters per second. And then 8 meters per second southwest. So after this, it moves 5.8 meters per second southwest. So dito yun banda. Yan. We're going to illustrate it as a bit longer than 5 since it's 8. So that will be 8.00 meters per second. That will now be velocity 2. Calculate the resultant velocity of the particle, meaning we have to calculate its resultant vector. Now, katulad kanina, we can create our table here. We have two vectors, that velocity 1 and then velocity 2. And we're going to have here our resultant velocity. Divided into 2 dimensions, that's the x and y. You have v1. Then we have v2. For v1, it's pretty much straightforward since it's already east, meaning that it's on the positive x. So this is already 5. Wala siyang y component, so that would be 0. However, our situation will change if we try to find the component vector of v2. So I'm going to isolate v2. So this is now your v2, 8 meters per second. Now, I can choose any angle. Pwedeng dito naka-base sa negative y or pwede rin sa negative x. I'm going to choose negative x. It's on the southwest, meaning it should be half of a 90-degree angle. So this should be 45 degrees. So that's now your angle. So v2 is now 8 meters per second with an angle of 45 degrees. And then, finding the x and y, we have here our v2x. It should be negative since it's directed towards the left or the negative x-axis. Di pa natin alam kung anong value yun. We're going to find it later. And then, we'll have here, again, a negative y since it's pointing downward. So this will now be our v2y, but still, we don't know the values there. We're still going to use the SOHCAHTOA. So for our last example, we'll have this. An unknown particle is moving at 5 meters per second east, and then 8 meters per second southwest. Calculate the resultant velocity of the particle. So basically, we have to find out its resultant vector. So let's illustrate that first. Sabi, meron daw tayo ditong particle, and it's moving east. So this is the illustration for that. It has a velocity of 5 meters per second. Afterwards, it moves 8 meters per second southwest. So that will be here using the tip-to-tail method. And it is now significantly longer since it has a higher magnitude than 5. So let's call this V1 and then we'll call this V2. 8 meters per second. So what we're going to do now is use the same strategy. We have to first create a table to allow ourselves to organize our values. That would now be divided into 3, the vector forces, which would be V1 and V2, and of course, the resultant vector. We have x and y dimension. So we have V1x, V1y, V2x, V2y, Rx, and Ry for their components. We can actually just plug in the value of V1 here since it's directed east, meaning it's on the positive x dimension. So we're going to put here 5 as 5 meters per second and 0y since it has no y component. But for V2, we're going to have a different scenario. So I'm going to illustrate V2 again here. V2 is going on this direction, meaning if we try to do a tip-to-tail method, it should have a component vector which is directed towards here. And it's on the x-axis, so we'll call that V2x. V2x. And it will also have a y component since you can see here it's going downward. So, still tip-to-tail method. And then we'll call this V2y. What will now be the angle of our V2? Basing on the negative x, we're going to have here our angle. And from this direction given to us, southwest, it should now be in the middle of south and west, whereas the south and west is a 90-degree angle. So the half of that will now be 45 degrees. So our theta here, theta will now be 45 degree with a magnitude of 8 meters per second. We now have to search the component of V2 in its x and y, or we'll have to search for V2x and V2y so we can put here on the table and now we can add them. So to do that, we're going to still use the SOHCAHTOA. First, we have to analyze what part of the triangle would be V2x and V2y. So for V2x, we can see here that it's adjacent to the angle. So V2x is adjacent to the angle. So using SOHCAHTOA, here, this would be ka, meaning it should be cosine. That will now be the shortcut. Now, basing on our knowledge or information a while ago, the formula here would now be V2x is equal to the hypotenuse, which is V, to ka, that will now be cosine, and then theta. Plugging in the value, that will now be 8 cosine 45 degree. So the value of our V2x is 8 cosine 45. That is 5.656. So 5.66. 5.66 meters per second. Now, looking at the illustration, V2x is actually directed to the left or to the west. So this would be negative, meaning our value here would be negative 5.66 meters per second. So that is the value of our V2x. So we can plug it here, negative 5.66. Now, solving for V2y, let's put it here, V2y. It is now on the opposite of the angle. As you can see here, it's now on the opposite of the angle. So we have to use SO in the SOHCAHTOA. So that will now be V2y is equal to V2 sine theta. Now, the angle is 45 degrees, so they should have the same value. But for computational purposes, we're going to do it still. 8 sine 45 degree. And again, that should be 5.66 also. So 8 sine 45. And there it is, 5.66 meters per second. So that will now be our V2y. Now, what will now be the sign of this? So still, V2y, as you can see here, is directed downward. So that will now be the negative y-axis. So this should be negative 5.66 also. So this is negative 5.66. Okay, now we have our value of our V2x and V2y. We can now add the following vector forces on the same dimensions. So this will be negative 0.66. This will be on negative 5.66. Remember that you have to add. So this would be 5 plus negative 5.66. This will be 0 plus negative 5.66. This is now our resultant vector in component form. So if we want to illustrate that, so this is the x-axis, it's negative 0.66, about this size. And we have negative 5.66, so it will be about this size. So this will now be our V2x. This will now be our, this will now be our R2x. Rx, this will now be our Ry. And the resultant vector itself would be this image here. Okay? So what will now be our value of that resultant vector? Since ang pinapahanap sa atin is calculate the resultant velocity. Now, we all know from the previous video that we are now going to use the Pythagorean theorem. We're going to have R is equal to the square root of Rx and Ry squared, Rx squared plus Ry squared. So, plugging in the value, we're going to have 0.66 and then 5.66. Now, pwede natin hindi lagay yung negative since it will be squared din naman. So, let's write here 0.66 squared plus 5.66 squared. Okay? So, computing that will be square root of 0.66 squared plus 5.66 squared. Value there is 5.70 since it's 5.69. So 5.70 meters per second. So that is now the value of our resultant velocity. So this is now your final answer. We can still search for the angle here, but ang tinanong lang naman sa atin would be the resultant velocity. Before we end this lesson, let's try our knowledge. Please answer on your own. These are physical quantities that has both magnitude and direction. Answer is vectors. Next, these are physical quantities that has magnitude only. Answer is scalars. Length, volume, and area are examples of physical quantities which are scalars. Next, displacement, momentum, and force are examples of vector quantities. These are mathematical representations of physical quantities that has both magnitude and direction. Answer is very good. Next, the length of the arrow signifies the direction of the vector. Now, is it true or false? This? False. The direction of the arrow signifies the magnitude of the vector. True or false? Very good. The length of the arrow is actually the magnitude of the vector, while the direction of the arrow is the angle or the direction of the vector. Last one, we can purposively move vectors as long as we don't change the length and the direction of a vector. True or false? Very good. That would be all for our first pre-recorded video. I hope you have achieved our objective. So by now, you should already know how to add vectors using the graphical and analytical method. See you next time.